Hey, today I want to talk briefly about the Girls Hackathon starter code. So I don't think I'll probably go into every single detail, but my hope is that I'll at least give you a little bit of direction to move you along or get you started with your project if you decided to use the starter code as your starting point for your project. So I mean, the first thing I want to say is there are directions for the starter code. They're pretty thorough in my opinion. I'm not saying that they'll answer every question that you might have, but I think they're a really great reference. So if you do have any questions, I would always start by going to it. Looks like some of the bookmarks are not working, but regardless, the rest of it should be perfectly fine. So again, I would look through here if you have any questions. It has a nice introduction and walks you through every single class that's a part of the project. Now, I'm not going to spend time reading through or looking through those directions because it's obviously something you can do yourself, but I do want to look through the code itself. And I will say that I think this project can appear a bit intimidating at first because of the amount of files that come along with it, right? So we have a ton of image folders and then files inside of those folders, right? But I think more importantly, we have a ton of classes that I wrote. So um, there's all sorts of classes in here. Really, where the project starts is with this graphics main class. Now, you're not going to modify this class unless you want to change the title for the panel that pops up, in which case you just change that here. Really, I'd say 99% of the work that you're going to do or the code that you're going to modify is going to be done in this graphics panel class. So that's personally where I would start, right? If you take a look at this graphics panel class, at the beginning I'm declaring a couple variables. So we have a timer. A timer is basically just used to move things on your screen. It's going to basically be used to make something occur every so many milliseconds. Whatever that something is up to you, but it gives you the ability to do that, right? So if you want to move things, whatever you want to do, this timer is going to allow you to do that every so many milliseconds. With that being said, I will say you don't want to use loops in general with this project, right? If you're trying to move a character across the screen, you're not going to use a loop to do that. The timer is basically going to be the looping structure for this project. The only time I would say you would use a loop is if you had some sort of array or collection of objects and you wanted to loop through the collection. But other than that, I can't think of why you'd want to use a loop. Okay. Next thing we have is a background. So the background object is just like it sounds. It's going to be used to draw something on the background of your screen. Now there's a bunch of different backgrounds that you can choose from. Unfortunately, they're not grouped real great, but we have a desert background, forest background, graveyard background, and track background. I think that's it. If you want details about what those are going to look like, again, just look at those directions. But regardless of which one you choose, right here we're declaring an object that will be the background. And you'll initialize it later on, and I'll get to that in just a moment. All right. After that, I have a sprite. A sprite is really, well, it says it right here. It's an abstract class. An abstract class means it's a class you can't directly instantiate. But instead, what you can instantiate is any one of the sprite subclasses. If you're in Comp Sci 2, some of these terms I recognize you probably won't know yet, and I apologize for that. But regardless, right? The idea is you have this sprite class, and then the sprite class has a bunch of classes below it. So here are all the different sprites. So you can see it looks like a cowboy, a cowgirl. I forget what they're called exactly. You have a boy, a cat, dinosaur. That's a dog. I think it looks like a fox, whatever. A girl, robot, zombie boy, and zombie girl, right? So these are all the different characters that you can create for your game. Now, you can obviously rename this object. So maybe, let's say you wanted to create a girl, you could say private sprite girl. Let's say you wanted more than one character, you could declare multiple variables, right? I could say private sprite girl, and then later on private sprite cat, private sprite dog. You can even have obviously multiple instances of any of those classes. So you could have more than one girl sprite if you'd like to, right? But however you decide to do it, you just want to make sure that you're declaring them all right here. So, I mean, I'll just type one up real fast as an example. So I might say something like private sprite dinosaur, right? And I mean, the fact that it's called dinosaur is irrelevant, right? I'm just trying to be descriptive because obviously this is later going to be an instance of my dinosaur class, right? But you can declare as many characters, and I call them the sprites, but again, you can declare them right here. All right, the last thing that we have is an item. So sprites are basically things that will move around the screen, like the girl or what things we just looked at. Items are inanimate objects that you can place on your screen. And again, if I look over at the directions, I don't remember exactly where this is, so I'm hoping my bookmark failed. That's too bad. We'll just try to scroll down real fast. I think I put pictures of each of the items on here, but I'm not sure. I don't remember exactly. Okay, so I didn't have all of them, but here are a couple examples. You can see there's like a tree, a rock, a sign. It looks like a sig. It looks like it got cut off. So you have these items that are things that are going to appear in front of you, and then we also have these things called tiles. So if you wanted to draw something in the background, you could use tiles. Now, where would you find all these items? The easiest way to do it is just down here in the images. So if I look, let me see if I can find the right a good folder. Yeah, here we go. So you can see I have images, forest. That's going to first be the background itself, right? So this is one of the backgrounds. But then related to that forest, I have different objects that I can draw on it, right? So these are the different objects. There's a sign, right? And then below that I have the different tiles as well. So I don't know what tile 12 is going to look like, but if you wanted to build something in the background, you could use all these tiles. So that's just with the forest, I'd say, theme. You can do the same thing with graveyards, although it looks like that graveyard objects folder is empty for some reason. But yeah, you can do quite a bit with drawing in the background. Okay, so again, you can add as many of these items as you'd like. I'd probably declare them all up here. If you know arrays or array lists, probably be best to put them inside of an array if you plan on adding quite a few. If you don't know arrays yet because you're in Comp Sci 2, then you can just declare all of them right there. Okay, so those are my variables. Next thing I have is my constructor. All right, inside my constructor, I need to initialize each of these variables that I declared up top. So you can see that I'm starting by declaring or initializing my background. I made it a forest background. Again, I can set this variable equal to any of my different types of backgrounds. So let me just run it right now, and then I'll change that background and show you what happens. Oops, that's the wrong project. Sorry about that. Before I can run it, I've got to select graphics main. Okay, so there it should be, right? This is my forest background, and I've got a cat on it. Alright, so I'm going to get rid of that. I'll stop it, and I'm going to change this to instead be a desert background. Alright, and I'll run it. And when I run it, you can see the background change. And I did set it up so that the size of the panel changes automatically with the image, so you don't have to worry about that, right? And again, there's all sorts of different backgrounds that you could choose. I'm going to probably leave it at this for right now, okay? Next thing we have is a tree. Now, when we declare objects, it's a bit different than a lot of what we're doing with the rest of this project, right? Like if I wanted to change the background image, I would just set background equal to an instance of a different class, right? Whether it's a desert background or a graveyard background. When we declare objects, or items, I should say, instead of setting it equal to a new class, all we're going to actually do is change the path. We're going to change the path, okay, for the image itself. So you can see right now, this tree is going to be in my images folder, which everything is. All my images will be inside of the image folder. Then forest, so let me find forest here. I hope I can find it. Images, forest, right? Then the objects folder. So if I go to images, forest, objects, I should see tree underscore 2.png. If I wanted to draw something else, I think I'm in my desert, so let me grab an object from my desert theme instead. So I'm going to change this from forest to images slash desert slash, I'll leave it as objects, and then I'm going to draw a saw. I have no idea what this saw is going to look like. And last thing I will say, this parameter right here, um, it's a scale factor. So if you want to make it bigger or smaller, you can change this number. So it says what the scale is used to make the image smaller. So the bigger the scale, the smaller the image will be, which might seem a bit counterintuitive. But if I wanted to make the saw much smaller, I could make this 5 or something. And let me run it and see what this saw even looks like. All right, well, that's quite the big saw. I'll probably make it a bit smaller. So let's change that to 4. And it should be 1/4 the size, I believe, as it was before. Yeah, there it is, right? And you'll notice it seemed to move up. That's because the X and Y corners are always going to be the top left-hand corner of an image. So as I make it smaller, it's actually moving up and to the left. If I wanted to change where it was drawn on the panel, I would change those first 2 parameters, right? This is the X coordinate of the top left-hand corner. This is the Y coordinate, where on our panel, 0, 0 is always going to be the top left-hand corner, right? So this is 0, 0. As you move to the right, X increases. As you move down, Y increases. All right, so that's my object. Next thing I have is my sprite. So in this case, my sprite is currently a cat. I want to change that, so I'm going to change it to a robot. How would I do that? Very simply, I would just change the class from cat to robot, and once again, I'll run it. And when I run it, you can see I now have a robot there. We'll get to that square and why it's there in just a moment, but ignore it for the time being, and you'll just see, focus on the fact that we're changing the sprite type. Okay. After that, don't worry about the set prefer size. Don't worry about any of this timer or focusable and add key listener stuff. You can just leave that be. It's important, but I don't think it's necessary that we understand it. Okay. So the next function that we come to is called paint component. Paint component is a function where we're going to draw everything on our panel. You shouldn't be doing anything else in this function other than drawing. The other side of that is, though, this is the only place that you can really draw. Okay, so you'll notice that the first thing I do is just declaring this graphics 2D object. Don't worry about that. I'm drawing the background. When we draw on panels in Java, it is layered in the sense that whatever you draw first is going to be on the background. And then as you draw additional items, they kind of get stacked on top. So that's why we always want to draw the background first, so it's the lowest level, our layer. And then I'm drawing the tree. I'm drawing the sprite. You'll notice that in order to draw any of these objects, I simply call its draw function. So all these classes have a draw function. I don't know why I switched these two around. I probably shouldn't have done that. But regardless, just pass it the parameters G2 in this. You don't need to understand that. Just know that if you do that, it will draw the objects for you. Now here, I'm drawing a rectangle, and this is different and maybe interesting, right? I'm drawing a rectangle around my sprite, and I'm calling the getBounds function from the sprite. Kind of interesting, right? What does getBounds return? Well, I'll give you a hint. It returns a rectangle, right? So let me see if I can find that function. I think it's just in my sprite class. Yeah, here it is, getBounds, right? So this getBounds function is going to return a rectangle, and then in my panel class, I'm using that rectangle to simply draw a rectangle around it. Now, honestly, I'm going to comment this out. I don't think it's really necessary, but if you wanted to see what the rectangle looks like, you can do something just like this. Now, what's the purpose of a getBounds in a rectangle? Really, the primary purpose of it is for collision detection, right? Like right now, when the character collides with the object, so here he goes, he's going to die, right? So there he is, he died, and that way it looked pretty good, I think. But if I approach him from the other side, it's not going to be nearly as great. And you can see, I'll move up, and there he is, he died, and it didn't even remotely look like my robot intersected with the saw. But you can see this square that I drew is the actual bounds of the robot, right? So the idea is there's this image, right? The robot has an image, and it's a PNG, and there's a transparent background. So this rectangle represents the actual bounds of that image. If you wanted to change or improve this collision detection, you would have to go into the sprite class and modify this rectangle class so that perhaps instead of returning just all the values directly from the image resource, you could make it narrower. So I think I have what x coordinate. I'm not going to get into that right now. I could do that. You can ask me questions. I'd be happy to answer them. But if you're concerned about the bounds, this is where you're going to want to look. Okay, so I forget where I was at. Let's go back to the graphics panel here. Right. So again, paint component. We're drawing everything. Right. Now we move down to the clock method. This clock method is called every, I think it's 25 milliseconds. Actually, every 5 milliseconds by our timer. Right. So every 5 milliseconds, this clock method is going to be called. Where'd it go? There it is, right? So again, this is kind of the looping structure for our project, right? It's going to call this method every 5 milliseconds, and we're going to do something inside of this clock method. What are we doing? Well, we're going to move the sprite. So the sprite has a move function, and when we call it, it's going to move. We'll talk about how it moves and how it knows which way to move once we get down to the key press method. But for now, just know that basically any sprite or character that you're going to want to have move across the screen, you're going to need to call the move method, its move method, inside this clock method. All right. Here's where I'm checking for collision, right? So you can see if my sprite collides with the tree, collision is a function in my sprite class. So let me go over to my sprite class. There it is. And you can see it's just checking to see if this object intersects with the item that it's being passed. You'll notice there's two of these functions. They're overloaded. One is pass another sprite. The other is pass an item. So if you wanted to say, see if the robot intersected with a dog, you could call this collision function. If you wanted to see if it would intersect with a tree, you could call this other collision function, right? So in my graphics panel right now, I'm checking to see if my sprite collides with the tree. If it does, and this is just a Boolean expression, right? If this function returns true, then my sprite is going to die. If it doesn't return true, then nothing's really going to happen. And this line of code is very important. After every single clock function, we're going to repaint our panel. And Java is pretty inefficient with graphics. It's going to redraw everything, but that's not important for us. Just know that you need to leave this dot repaint inside the clock function. Okay. So that is the clock function. Next thing we have is key pressed. So there are several methods that are members of the key listener interface. Again, if you're in Comp Sci 2, that doesn't make sense. Don't worry about it. If you're in AP, that should make sense, right? So there's several key pressed functions inside, or excuse me, several functions that are members of the key listener interface. Okay. One of them is key pressed. When you press a key, this function is called. The other is key typed. Key type basically is just like the name sounds. It consists of both pressing and releasing. So if you type a key, this function is called. Third and final one is key release, and again, that's called just like the name kind of would imply, right? When you take your finger off of a key, this function is called. All right. So here we have key press. When I press down on a key, it's going to call this function. It passes it one parameter, which is called or of type key event. A key event basically has all the information about the key that was pressed. So normally I like to do this in a switch statement, but we just did it in a series of if statements for simplicity's sake for the girls' hackathon. But basically I'm going to check to see right here if the key that was pressed, so if E, my parameter, if its key code is right, VK underscore right is just a constant for the right arrow, and there's these constants for every single arrow on your keyboard. If that key was pressed, I'm going to say sprite dot walk right. This would change the direction that the sprite was going so that he's walking right. Clearly I have walk left, move up, move down. I have a run function. If you press the space bar, it will cause him just to speed up and run faster. And then there's a jump, and there's finally a die function. I don't know why you'd want to have a key that makes your character die, but whatever, there it is, right? So I could run it and demonstrate these things, but you wouldn't see me pressing the key, so I think I'm not going to do that, right? But again, you can call any sort of functions on your sprite class when any of the keys are pressed. I chose these keys, but if you wanted to use other keys, you could. If you wanted to have two characters and maybe one of them it works with the arrows and the others works with WASD, you could do that as well. Here's the only thing I will mention, and students often get confused about this. You can't like detect more than one key at a time. So you can't say something like, if it's right and the space bar, then do such and such, right? It only detects one key event at a time. So that can be confusing, but yeah, it is what it is. All right, skipping over this key typed, let's go down to the key released. Again, the key release function is called when you release a key. So here I'm saying if, let's say they released the right key or they released the left key. If they do, then I'm going to stop my sprite from running, and I'll show you this, right? So I'm pressing the right key, there he goes. I'm going to speed him up, I'll press the space bar. All right, I released and he stopped. All right, I'm going to start going left, release, and he stops. He starts to idle, right? Let me try jump. There's the jump. That's a slow, weird jump. I forget what other things I had in there, right? But the idea is when I release the key, if the key is released, I'm just doing some sort of motion, right? So if it's right or left that was released, I'm going to stop moving left or right by calling the idle function. If a up or down arrow was pressed, I'm going to stop my vertical movement. And then finally, if it was the space bar that was released, the guy's just going to slow down. All right, so I think that's all the graphics panel starter code. And I think that might be all that I'm going to discuss for today. Now, I'll be holding sessions whenever we're scheduled for math, the math sit time. So if you hit any questions, you can obviously send me an email or maybe write them down and have them ready to go when we do meet. I want to help you guys as much as I can. I think I really like this project and I like this starter code because y'all can do something really cool and really amazing with it. But the flip side of that is it's a lot to get started with, right? There's just a lot here. And reading code and understanding code that somebody else wrote is not easy by any means. I find it's often easier myself to just start from scratch because then I know everything that's going on underneath. Right here, this is code that I wrote, and you're trying to jump into the code and read and understand it and go with it. So that's a new skill. It's a difficult skill, but I hope it's a skill that you can start to feel comfortable with, and hopefully this project will aid in that process. So again, send me an email, ask questions during the sit sessions if you have questions, and then other than that, I'm really excited to see what you all are going to create.